Hi everyone, so today I'm going to show you how to use the electrical test equipment. Basically, a series of tests have to be done to verify that cables and connected devices are safe to operate on for the completion of the wiring and installation. An inspection must be done before the tests are performed. I will turn on my multimeter to the desired test function and check to see if it is in working condition by touching the two leads together. Most multimeters will beep when touched together. The value on the multimeter will either show a 0 or a low value. This is because some multimeter will be checking for voltage or resistance when testing for continuity. I can now place the probe on two connection points and I should hear a beep. I will do this again but on two parts that are not electrically connected. There is no beep, and the meter indicates an OL. Now I will use a cable with color-coded conductors to show how the meter can check for continuity. As you can see, the blue wire on each end has continuity when tested. I will now use a different cable that has the same color conductors. I can use one test probe on a wire and then use the other test probe on each wire on the other end to find the appropriate connection. This can help trace back on a labeled wires or to verify connection from one device to another multimeters. How to determine the polarity of a power supply? Sometimes you'll get a power supply you are trying to hook it up in your circuit, but you don't know the polarity because say the both power supply wires are black. In this case, I've just got two black wires that connected to my benchtop power supply. I'm supplying 9 volts. Many circuits without protection, if you reverse the polarity when you power it up, you will blow your caps, you'll maybe blow your regulator, and you'll fry your chips, etc. So here's how you test. Take your multimeter and set it to DC voltage and then you take your two probes and you probe both lines. You will notice that the multimeter says negative 9.12 volts. That means that I have my probes reversed. What I want to see is 9.12 volts or 9. Whatever 9.12 volts. So I don't see that negative sign. So that means that the wire connected to my red probe is my positive 9 volts and the wire connected to the black probe is ground DC. So if you hook it up backwards, you see the negative sign. If you hook it up properly, that is how you determine the polarity. So I will connect this wire to my power supply by positive power supply pin and I will connect this to the DC ground line on my circuit. Now, this tester has got three terminals, live, ground, and earth. We will be using ground for this video, so we will ignore it. And why mine's got live and earth? You also have positive and negative on it, top, plus or minus, so just bear that in mind. You first of all take your red test lead and plug it in the positive one. In this case, the live terminal. You then get your black lead and plug it in the earth terminal, or maybe the negative terminal in your case. You then first of all go between live and neutral. Set your test voltage. In this case, I will satisfy from the voltage pretty much, the standard for the single phase voltage. Then test it. Take a reading, then go between live and earth. Test it. Take a reading, then give it wing earth and neutral. Test it. Take a reading, and then finally add go between all the conductors to the outer sheet. So I will just heat up this purpose and then I will go like so to all connect this to the outer sheet. That's it, and take your reading. As you can see in this case is over 2000 ohms. So I've got a max out, and that sign as you see, what that means is beyond what the display can show. So that's the basic of how we test for the resistance inside cable. The final instrument test is normally the RCD test. This will be carried out while use an RCD tester, but really the easiest way to talk into the test is to show you the scale on the test instrument. On this instrument, it's got a scale for half time, 1 times, and 5 times I delta n. These tests are carried out at half times. The RCD shouldn't trip. At 1 time, it should trip in less than 300 milliseconds, and at 5 times, it should trip in less than 40 milliseconds. Quickly, I will just take you through the test, leaving it on hard times, and on 30, I press the test button, and it says overscale, showing that it hasn't checked. Move it to 1 times and press to the test button. It should trip in less than 300 milliseconds, and it tripped in 28 milliseconds. And move on to 5 times and press the test button, and in this case, again it tripped at 28 milliseconds. This instrument has a function for the sinusoidal waveform 0 and 180. So you will click that cross and carry out the test again at 1 times and 5 times. But there's no need to test half time because that was just ensuring the nuisance tripping doesn't take place.